Greetings and welcome again to CSCI 230 Data Structures Online. I'll be your instructor. I'm Professor Emily Hill. I direct the CS program here at Drew University. And for this course, we will have virtual office hours. But please keep an eye out for updates on the times because they may change based on student availability, and I'll post those messages to the discussion board so you can see them. So in data structures, we are going to be looking into how do we effectively organize data in computer programs. I have a recommended textbook that I like. It's called A Common Sense Guide to Data Structures and Algorithms. It's available as both PDF and a textbook, a hard copy physically. It is a recommended textbook, but as a computer scientist, a really important skill to develop is how to select your own learning resources. If you would prefer to find other resources that may be different, may be free, may cost money, you are fully able to do that. I won't restrict that. In this course, you are allowed to select your programming language. So I would pick your favorite, or if you're a super passionate programmer who wants to pick up a new language, you're welcome to do so as well. So popular choices in the past for students have been Python and Java. Other languages are also an option. They must support loops and functions. And so some languages, for example, that's not as easy to do. For example, R is a little bit different, or SQL, right? These are languages that wouldn't lend themselves to this course. But Python and Java are very popular choices. If you want to use something else, just run it by me first so I can make sure that it seems like an appropriate language for the course. You will need a computer and you'll need a programming development environment for your language of choice. All of the course materials and content will be available to you through Canvas. The link is on the syllabus. And so here is the course itself. We have the home page, and then we've got links to the syllabus, the schedule. All materials are going to be available through Google Drive, and all discussion will be through a shared Slack channel. So Slack is this really awesome platform for discussion and coordinating content. So we'll be using Slack to communicate. Any announcements I have to the class, I'll be posting here. Also, if you have questions, don't email me. Please, please, please don't email me. I get a ton of email and I don't want to miss your question. So what I ask is that you submit your questions to Slack. You can either submit it to the full general channel, or if you have a question about a particular topic, you can post it there. I highly recommend that you post it more generally where all the students can see it, because I may not be able to answer it as quickly as another student might be able to. For example, if I'm not online at the time that you are posting, or if I'm asleep, or if I have other things going on. I do have some children that take up some of my time as well. So I check regularly and frequently, but I may not be able to respond as quickly as another student in the course might. The other reason to use Slack is because I get so much email, I prioritize Slack. If I see a message there, I'm going to go there first before I start checking email. And so I highly recommend that you use Slack for all course-related communication. If you're concerned that you might be sharing code that would be considered cheating or would disrupt someone else's learning or educational experience, then you can feel free to message me directly. There to the left here, there's places where you can message any other person in the course. Okay, so those are the two means, Canvas and Slack, and then also the Google Drive materials. That's where all the materials are. So I will link everything on Google Drive to Canvas for assignments and learning materials, but if you wanted to look ahead or just kind of browse everything that's available, you're welcome to check out the Google Drive folder. In terms of assessment, a really important component of this course is engagement, and this is actually worth 10%. So we're trying to build a community of learners together, all devoted to spending the coming weeks mastering data structures and algorithms. So you're expected to work through any practice homework exercises or readings, actively participate in learning activities during group meetings, and online on Slack by posting questions on anything that's unclear to you, as well as posting responses to other students' questions when you have knowledge to share. And engagement will be assessed in an ongoing manner throughout the summer session. At minimum, I will post a mid-semester or mid-session report on your engagement, as well as at the end of the semester. I will assign a number of practice exercises. These are worth 0%. They are not graded. However, I highly recommend that you work through them. So I create, for every assessment, every quiz, every exam, I create a self-assessment that's as close as I can get as possible to mimicking the real deal. So I highly recommend that you work through those and practice and give yourself the confidence so that you can really succeed and thrive during the assessments. There will be some homeworks. Those are worth 10%. They provide early feedback on your learning progress, and they might be coding progress, a worksheet, or a vocabulary quiz. Typically, the worksheets I assign, I ask that you can complete them online, using Word or Google Docs, or you can print them out and just write on them. I really don't care. During class, I hand them out, and if you prefer to write on your course materials, just take a picture with your phone and upload it. So I'm not looking for a pristine copy. I just want to see that you've worked through the homeworks. Homeworks typically are not graded for correctness. They're graded for completeness. Quizzes are 10%, and once we've explored a topic through practice exercises and homework, then we demonstrate mastery with a low-stakes quiz, and they provide valuable feedback on your learning so we can see what needs more attention and where we're succeeding. There's also going to be 4 programming projects. 3 are from scratch, and 1 is using an external website called HackerRank. So the programming projects are worth 40%, so each one is worth 10%. And so these provide a means for us to master the concepts, not just in theory, but also to apply your newly developed knowledge by implementing programs that explore these concepts. And so 3 of the projects will be from scratch. You can use whatever language you want. You can change your language in between every project. You can do the first project in Python, the second one in Java. It's completely up to you, completely your choice. The final project will be using an external website called HackerRank that is often used to help round out a student's resume or portfolio before applying for jobs, and helps demonstrate mastery in a standardized way. And so we'll be using the problem solving section of HackerRank, and it'll show up right away as a homework, and then during the mid-semester I'll ask you half of that final project, and then the remaining exercises will be due by the end. So there's really 3 projects spread out over the course, and then the final project can be done at any time. There will be a final exam. There won't be a midterm. This class is a little bit too accelerated and quick moving to have time for a midterm as well as a final exam. The exam is worth 30% and it's cumulative. The final quiz will be, in some sense, a pre-midterm because it will have similar questions that will show up on the midterm. There will be a self-assessment that shows you the style and approximate number of questions that will be on it. So you'll be able to really see if you're ready for that and master. All assessments, quizzes, and exams are timed. Programming projects are just due like a normal homework, but the quizzes and exams, once you begin them, they do have a time limit on them, because normally in a face-to-face course, I ask my students to complete these exercises, these quizzes and exams on paper, or they don't have any resources. So the way I mimic that in an online scenario is by timing it, so that you have to have mastered the concepts well enough to complete the exercises in a set amount of time. Okay, so that's the syllabus. And again, if there's any questions, please don't hesitate to reach out. So there's also a schedule. It's linked on Canvas and it's in the Google Drive folder that describes the modules. We have 5 modules in this course plus the final. And the first one is fundamentals, with a project to get us started working with our first data structure, which is dictionaries, although I guess the very first fundamental data structure is an array. And so we'll be working with that. One other thing I haven't mentioned yet is that we'll be working mostly in pseudocode, because all of the students are free to choose their own programming language, Java or Python. The content of the course will all be in a language called pseudocode, which doesn't really resemble any one particular language completely, but it looks like them all. And so the great thing about pseudocode is you don't have to worry if your semicolon's in the wrong place, or if you use the right keyword or the right function name, as long as it's clear, and that if you gave your pseudocode to two separate people, that they would be able to code it up and give you the same working solution, then it's detailed enough. And so we'll get into that in the first lesson. Okay, so after we talk about the fundamentals, we'll talk about recursion, which are functions that call themselves. There will be a quiz related to that. We'll talk about algorithms and how we assess and compare two algorithms in terms of which one is more efficient, which is called Big O. There'll be a quiz related to that. And then we have a couple more projects. We'll look at sorting, and so we'll look into timing our operations and putting that efficiency into practice. And then finally, we'll have ADTs, which is short for abstract data types. So linked lists, stacks and queues, and binary trees. And so with this final module is a little bit bigger than the ones that have come before. And so it will have 2 quizzes and a project, as well as the final project. And just to give you a sense of what this looks like, so the course materials will all be made available through Canvas. And so when you log in, the syllabus page is the home page. And if you want, you can just look at the modules. That's a more curated and organized way to look at this material. And so for each module, I will have a list of all the deliverables and learning materials that are available. And the videos will be posted in an ongoing way. If you have a question, sometimes my content will adapt based on where students have questions, and I'll post additional materials. When I post additional materials, I will notify you via Slack. Okay, you can also see the calendar of everything in the course. If you click over on calendar, you can see what the deadlines are. I will try to have deadlines twice a week. There could be as many as 3 deadlines in a week, but I will try to consolidate. However, the way this course is designed is it's really a condensed course. So typically the summer classes I teach run for 5 weeks, and they are taught 3 days a week for about 3 hours a day plus some homework. So you'll want to plan to spend about 10 to 12 hours per week on the content itself, and then you may need additional time for the project. So you just want to carve out that time so that you can set it aside. I'm consolidating the deadlines so that you can better manage your schedule, but what I really recommend is that as soon as you log in for the week and you see what the assignments are, is that you do 1 a day until that deadline. However, I get it, life happens. And so I've tried to consolidate the deadlines to help you manage your time in the most flexible way possible. The other thing I forgot to mention is my late policy. I give 75% credit for late submissions up to 1 week after the deadline, and no credit after that. The way this works is that I typically make my deadlines at midnight. I value your well-being and health, and I think you should too, but I understand, again, that life happens sometimes. So the late penalty doesn't go into effect until it's the next day everywhere on Earth. So if it's still midnight somewhere on Earth, your assignment's not late. If you're in Eastern Standard Time, that's typically around 7 a.m. And so that will be the policy for the late policy for the assignments. Okay. And so that concludes the information I have to share with you about how the course is structured and how it will run. But please don't hesitate to reach out if you have any further questions.